So finally, they have done it. Apple has pulled an apple and launched the greatest calculator ever. Math Notes is a game changer, turning handwriting into digital equations, solving problems, even graphing on the fly. But hey, wait, it's only for iPad. Not everyone has that. What about us Android and PC folks? Don't we deserve a better calculator application as well? Well, guess what? We are not just bringing math notes to the web. We are taking it to the next level. Basic arithmetics, child's play, solving equations, easy peasy. But that's not all. Our calculator can even calculate complex scenarios, like the time it would take for your Porsche to crash into that tree. Or maybe the answer to the life and universe and everything. It's like having a math superhero in your pocket. But wait, there's more. Our calculator is not just limited to math problems. It can even detect abstract concepts depicted in your drawings. For example, draw a chicken and an egg, and watch our app grapple with the age-old question, which came first. And if that was still not enough, our calculator can even find the deep meaning behind Captain America's shield. Don't worry my friends, we are not playing around in this video. We are creating this application. And don't you guys worry if you don't know a single thing about Python, React, or even calculators, because we are gonna learn everything today. Let's start with giving it everybody's favorite superhero, Captain America. Some red, white, blue, another red, and a little white star. And let's see what it gives us. This is the drawing of Captain America and shield. It is made up of red, white, blue, and this is a shield is a symbol of freedom and justice. Amazing. Let's try a Pythagoras theorem. Make a tree. There be shadow. We'll keep it easy. Not some really hard number. 8 meters of length and 6 meters of shadow or base length. Let's draw a little sun. And what will be the hypotenuse? It should be 10. Yep, that's correct. Should we try making a car crash into a tree? That's a common mathematical problem, right? Okay, let's draw a tree. Wood, leaves green, and the length should be what, 100 meters. Okay, and its speed should be something like 160 kilometers per hour. Boom, kabam, pow. Let's run it. I think that's the correct answer, 0.225. Okay, let's try asking it a more abstract question, underlying theme. Pardon my flag drawing skills, really. Okay, let's make some people salute our flag. That's our team, that's the Error by Nights team. Okay. And that should, let's see what it gives us. Patriotism equals patriotism. Okay, it's getting there. Another one to really demonstrate its capabilities, I think, let's draw a cricket wagon wheel with some runs all over the places. Let there be sixes, let there be fours, let there be singles. Different colors so that our app really recognizes, and we can give it this to recognize what colors each of the lines represent. And that should give us what, 6, 8, and 15, that's correct. Okay, one last one that I really want to test myself and check if AI has capabilities to detect folk tales or stories from real life. I think you all might have guessed it. It's Newton and Apple falling on him. Let's see what our AI gives us. Okay. Yep, a person looking the story of Apple falling on Newton's head, discovery of gravity. Alright, that was a lot of demo and intro setup, whole shenanigans. So let's dive in now. Let's start your favorite code editor and open up the terminal. We'll create our project directory. I'm naming it Math Notes. And we will be using Wit in this project. So let's create a new project using Wit, React, TypeScript. Let's open this project in our VS Code. And let's initialize our Tailwind files. Now we need to configure our tsconfig files. We .app and .node. We need to add a base URL and give an alias to the root directory. We will do it like this. That and same thing in the tsconfig.json. We also need to add the compiler options here. Now next thing we need to also edit our tailwind config file. Let's just go to their website and copy paste this. We also need to edit our index.css file. Just add the tailwind prefixes there. Now we will be using ShadScene component library in our project. ShadScene is a very beautiful and an amazing, very customizable library to create and reuse components. As you can see, there are various components here: cards, buttons, screen changers, text areas, select menu, radio button, drop down menus, hover cards, inputs, labels, and sheets. Let's initialize the ShadScene component library. Use neutral. You can use the default settings that are given on their website. Now let's open up our wit config, and we need to install node types so that we can easily use path function in our wit config. Next thing, let's try adding a button using our ShadScene component library. And that's done. Finally, we also need to edit our tailwind config file. Get the link in description for our tailwind.config.js and copy paste that content in your file. Now for the project structure, I usually use a screens directory where all my website screens are in. So let's create one for our home directory. Home screen. Here we will be using functional components. There are two kinds of components in React, functional and class components. You should refer to React documentation if you want to learn more about them. First thing we need to make is an HTML canvas where we can draw stuff. Here we will be using ref for our canvas with React's useRef hook. This ref is used when you want to store a value in your component but don't want React to re-render the component when this value changes. If you use a state, it re-renders after every change to state's value. Let's also return this canvas component from our function so that it is rendered on the screen. We will give it a class name of absolute and top 0, left 0, full width, full height, so that it fills the whole screen. Next, we need to know whether at the moment user is drawing or not. So we will create a state called isDrawing, which will be false in the beginning. To know when exactly user wants to draw, we can react to the mouse click event, because obviously to draw user will click and hold the left mouse button. So let's start with the function called start drawing, which will take a mouse event as an argument on the canvas element. And we have to initially configure our canvas by setting its background color and setting 2D context so that we can draw 2D drawings on our canvas. Begin path function will create a new path and delete older stored paths, and move to will move our cursor to wherever we want, in this case wherever the user clicked. Then we set our drawing state to true. And finally, we need to add an attribute to our canvas component telling it to call this function whenever mouse down event happens. Similarly, a simple function for stop drawing on canvas. This will just set this isDrawing state to false. Let's add it on our canvas as well. Now we need a function to implement the actual drawing method. Here we will take the mouse event as an argument, and if drawing state is true, then only we need to draw. So we will set our brush color to white using stroke style attribute. and then call line2 function to follow our mouse, and finally a stroke function to draw wherever the line2 function was called. Also, let's tell our canvas element to call this function wherever mouse moves. Finally, add a use effect hook when our website starts to initialize the canvas elements. This use effect hook will take an empty dependency array so that it does not run every time some state changes. It will only run when we start up the application. Now we are going to install Mantine, which is another component library like ShadCN, and we will also use React Router DOM to manage our application routes. Let's install React Router DOM, and we will use Mantine for its color swatch component. It has a very beautiful color swatch component that ShadCN lacks currently. You need to just copy paste what I have copied in this post css.config.cgs from Mantine's official website. Now let's write our app.tsx file. There are several routers in React Router DOM, like native router for your React Native applications and browser router for your browser application. There is also a memory router, but we will be using browser router here. Head over to its documentation if you want to learn more about routers. They are very useful when you create more complex applications. So browser router will be is used to just make routes for your browser application. It stores URL in basic URL format, and this router provider is an abstract component that takes in any router and provides a common API for all of them. Paths will be the array that will store all our URL paths in our application. And finally, our home screen component that we created. So pass this array to our router, and let's return our app component with router provider, which will use our browser router. Let's go test this app now. npm run dev. Let's go to our website. It's working great. We can draw whatever we want now. But it's quite boring. There is no color here. It's just white on black, and we do not have any way to erase what we draw. So let's try that. Okay, then I will first add colors. Let's create a file to add colors. Oops. .ts rm.t. Open that, and we'll write let's create this swatch for all our colors. I'm just copy pasting these colors I have already created. Let's export our file. Export swatches. Now we have to import these colors to our home page. And we will use Mantine's color swatch to display them on our screen. Let's also create a state which will hold the selected color. And just find and replace with Control H all the places we used white at with the color state. Now we need to add some buttons to our page, so let's import our ShadCN button. And we will also need a Axios library because we are going to be sending our image data to our backend server through Axios. First, let's create a reset button. For that, we need a reset state. Whenever this is true, we will have to clear our canvas and also clear other states. So let's use an use effect hook. It will just call a reset canvas function. We'll create a reset canvas function next. and in its dependency array it will take the reset state because it has to run every time the reset state changes. Now let's write our reset canvas function. This function will just clear our canvas. We will use the canvas's clear rect function for that. For first we need to get our canvas using the canvas ref.current. And we will just call the clear rect function here. We'll give our xy parameters there and the width and height of our canvas. Now to keep TypeScript happy, we will create an interface for our response. This will be the response which will send back from our backend server. We will send back expression, result, and assign. In a short while, you will understand why we selected these three specific values. We will need another interface for the result which we generate on our front end. It will hold expression and answer to that expression. It could be like x plus y equals 7 or 2 plus 5 equals 7, whatever the case may be. We will need another state to hold this result variable. It will use the generated result state type. Now we will need another state to hold a dictionary of variables. This dictionary of variables will be especially useful whenever we want to assign some value to the variables like x equals y, x equals 5 or y equals 8. Now let's create our send data function. This will send the canvas image to the backend. For our backend to analyze, this will take the canvas ref.current, and if it exists, we will send a post request through our Axios to our backend URL, which we have stored in our Vite API URL. It will have the data image, which will be our canvas image. ToData URL function will convert the canvas image to a image format like WebP, PNG. For now, we will just print the response we will get back from our server using console.log. Now let's add some buttons for these three functions we just created. We will have three separate buttons, or two buttons and one color swatch grid. So let's create a div with grid, three columns. It will have the first button, which will be our reset button. It will just set the value of our reset state to true. Set to true. It will be the we will use default chart scene variant and black color. Let's write reset here. Let's just copy this button for our calculate function as well. It will have calculate and it will call the send data function we created earlier. Now we need another div or another group for a Mantine color swatch. This will have, we will just map the swatches array we created earlier. Map function takes a callback and it will return the color swatch component with the key color, and the color it will hold is the color we created. And on clicking that, it will change the color state we created earlier to whatever color the user clicked on. To keep TypeScript happy, we have to write the type for our swatch color. It will be a string, as our set color state is a string. Let's go check if our app is working now. npm run dev. We have not installed Axios, so here that's why it's giving this error. Let's quickly install that. Now let's run this, and our app is working great. We can also select colors, blue, red, orange, and we can also reset our canvas. We just need to shift this to the top of the website so it doesn't interfere with our canvas. Okay, we just need to go to our index.css and remove everything from root to this media, and we can go back and check our canvas is working fine now. Our color palette and buttons are on top and everything is working fine. Okay, let's add our environment.local file with the Vit API URL there. And this will be the API URL, localhost on port 8900. If you have to deploy it, you will be writing your backend URL there. Okay, then we are ready to move to our backend. Let's create our Python backend project directory and also a Python virtual environment to keep our dependencies separate. I use the Django style project structure for a Python backends as well. We will create apps and a calculator app in that. We also will use Pydantic schema, so let's create that file, and finally constraints and environment file to store all our contents and our API keys. Let's add our backend folder to the VS Code workspace. Add folder to workspace, projects. We will be using Fast API for our backend instead of Django in this project. Here we will need an asynchronous server, so we create an async context manager. We will also add course middleware so that we don't face course origin errors. And we will put our server URL and port in the constants file so that it is easy to change it later. In the Fast API lifespan, we don't want to do anything, so we will just yield. Quickly want to explain what the Fast API lifespan is. Usually you'll have stuff like initializing databases or loading data from database or a remote server. Maybe loading up your machine learning model. It's basically the code that will be executed before your server starts up, and code after the yield statement will run when you close your application. That is after handling all the requests. Fast API will execute this code, clean up memory or saving your system state or whatever you want to do when your application closes. Now let's add our middleware, course middleware, and we will allow all the methods, headers and requests from all origins. That's why we put an asterisk there, that's a wildcard. Finally, our out to check our server health. It will just return a message that server is running. And now write our main blog for starting using on server. Now we have to make a constants file to store our URL and port. Before testing our server, we have to install the required libraries. We will need Fast API, Pillow, UVCon, Pydantic, and Google Generative AI because we will be using Gemini Flash API in this project. We will also need python.env to create and use our .env file. Now let's test if our server is running. Yep, so it's running. Let's go get our API key now. Let's go to Google Cloud Console and click on this link here. Now we need to create a new project. You click here and create on new project. We will name this project something like calculator notes, calc notes, let's do it. And we don't have any organization, so just click on create. Now after creating our project, we need to use this project to generate our Gemini Flash API key. So let's go to Google AI Studio and here click on this link. Sign in if you have not already. You probably need to create 2FA before doing so. After signing in, you need to click on get API key and click create API key. Select the calculated nodes project we just created earlier and click on generate key. Now our key is generated. Let's copy it and go back to our project. Now let's go write our Gemini API key in the .env file. Just so you know, a .env file is used to store your environment variables. That is usually either secret data or something specific to your environment that you are running your code in. So it's a file you don't want to expose on your Git repositories. Let me show you. Let me pull up my folder of Git repo for this. As you can see here, all the environment related files and directories should not be uploaded on Git. They are in my git ignore file. Now let's go back and write our API key. Let's import this API key in our constants file now. This load.env function automatically reads our .env file in the root directory, and we can access anything we write in that using our os.getEnv function. Now let's create our calculator analyze function in the utils.py, the utility.py file. Today we are going to be using Gemini Flash API, but shortly we will be creating another video which will cover how to run this locally using Olama and Llama models or Mistral models, so keep your eye out for that one. Now let's configure Gemini by providing it your API key we just generated. And now we can create our analyze function which will take in an image and the dictionary we created earlier. We will put this model initialization above this function because we don't want to run it every time the analyze image function is called, right? I serialized this dictionary of variables to a string using JSON dumps so that I can pass it in the prompt easily. For now, copy this prompt I have written from my GitHub repository, but fear not, because there will be another video in a couple of weeks which will explain you my whole methodology and prompt engineering behind this. So make sure to subscribe the channel to not miss that one. Now ast.literalEval, it is a built-in function to evaluate mathematical expressions which we give it in a form of a string. I added this error handling because I was getting some errors in ast.literalEval while fine-tuning and editing my prompt. You don't really have to add it, but you should if you want to play around with the prompt I created and in case it doesn't work correctly. Then we'll just add the assign key to answer accordingly and return the final array. Before creating our API route, we will create a Pydantic schema so that we can tell our fast API server to what data we should accept from specific routes. We will just give a string for our image and a dictionary for our dict of variables. Now we need to create a fast API route where we will send API requests to get back this result. By importing this API router, we can create fast API routes outside of the main.py as well. Now we will create a post API route. So in this post API route, we will explicitly tell fast API to only accept data if it is in the form of image data schema we formed earlier. We will use base64 to decode this image and then send these bytes to our analyze image function. Base64 encoding was done by the canvas when we called the function toDataURL there. Now let's return this to our front end with a message status. It's a good practice to add status success and status failure so that you can easily check your logs later if your application fails or acts weirdly. Final change to our backend will be just adding this route we created in our main.py for a unicorn server to handle. This will just have a prefix so that we know what will be the route for this application. All the routes created in this application will have the prefix /calculate. Whatever we write in the route, that will come after it. And with just that, our backend is completed. Now let's go check if it's working correctly. Okay, let's open our terminals. Calcafe, calc backend, run python main.py on our front end. Run npm run dev. Let's try drawing something here. 2 plus 7 equals, it should give us 9 now. No result. Let's try again. Again, no result. Let's check in our network tab. Okay, we are getting wrong URL here. I think we misplaced our .env file. Yep, now it's giving us in our .env. We have correct URL, I think. And we are also using correct URL here. Let's try printing this. Also log our URL import meta. Yep. Let's print that. Remove error. Okay, yes, it's printing incorrect URL. I think our .env file is misplaced. It should be in the root directory, not in the src. It should be in our calcafe. Let's move it there. Let's restart our server and front end. Let's open it again. Now let's try again. 3 plus 7. Correct result. RC image processed, and the answer is also correct. 3 plus 7 equals 10. In our backend, we can also check that. Yep. Alright guys, our calculator is working very beautifully now, so we can finish up our project. To finish up, I want to add a small little thing as well. Instead of boring plain text, we will be rendering our mathematical expressions to LaTeX. LaTeX is a typesetting system that produces very beautiful mathematical functions and expressions, so we will be using that. To render our mathematical expressions to LaTeX, we will use a library called MathJax. To install this library, we can go to this website cdn.js MathJax. Here you have to use version 2.7.9 because that's what I'm using. Now do some file search and click to show all files. Okay, now you have to search text mml am html.js. We will be using this one. Just copy the URL. Let's go to our code. Open our home page. Here in our use effect, which we will run only once when our application starts because it has only an empty dependency array, we will also want to load our mathjx script that we just copied. Document.create element. Oops. Paste. Sorry. Write script here. And script.src we will add our link here. Now write script.async true. Document.head we have to append our this child, so our script is loaded in our page. Now when we load our script, we need to create a window and config the latex configuration to help render our expressions. We'll add a callback function here with windows.mathjs.hub.config, and here we'll write text to Jax. This will not be a capital letter. And what's wrong here? Okay, we'll check this afterwards. Inline math, and this is the format of normal latex expression. It starts and ends with the dollar sign. And let's add this. This is how latex expressions are written in a normal latex editor or your code editor. We'll finally return a callback function here which will remove this script we just added here. Now whenever our result state changes, we need to render it to latex because we are storing the result in result state. For that we need a new state. Let's call it latex expression for storing our latex expression. That will be rendered form of our result. Const latex expression, and another function set latex expression here, which will be use state and array of string. And to set the position where we have to render this latex expression, we will make another state called latex position. Same thing, latex position. Use state array. We'll put some default value here instead of just number because it usually does not render in our visible screen if this number is not there. This will not be an array. I'm sorry. It will just be used it like that. Now let's create a use effect for the same. Use effect. I'll put result as a dependency array because we need to run this whenever the result state changes. And if result state, so that it does not run when result is undefined or null, we will run a function that will render the this latex expression on our canvas. It will take result and result.answer. Now let's create this function. Now this function will take our latex and convert it into a large expression and answer. We use / large in latex format. Here we take expression and in the format answer. I think this should work. Now we'll set our latex expression to this new value we just created. We are going to use a spread operator here to, in case we had already some latex expressions stored in our state, we'll spread them out. If there are many assigned operations like x equal to y, x equal to 5, y equal to 6, and we have to render all of them, we need to store them in an array. That's why we took array in our latex expression type here. Now we need to go to our canvas, and the boilerplate stuff we have written everywhere. ctx canvas get context. Oops. And if ctx is there, we'll just clear whatever image we had drawn there so that the image is replaced. It looks like that image is replaced by the latex expression that was rendered now. And here we'll close our function. Done. Now, whenever this latex expression changes, whenever this function is run, we have to create another use effect so it gets rendered into the required latex we want. Another use effect, and as you can guess now, we'll give latex expression array here, and in the function we'll just write if latex expression, if there is some latex expression in our state and our math.js already loaded. After some timeout, this is because this is an asynchronous operation. Hub you set typeset into message hub after a time of 0 seconds, 0 milliseconds, I'm sorry. We should also update our reset function to clear all these new states we have created. So let's go to our reset use effect, set latex expression to empty array, set our result to undefined, set our ticked off variables to also an empty dictionary, and I think that's enough. Now, final thing, we need to use our latex position to know where to render our canvas. We have to put them in our return statement. But before that, we need to edit our send data function, because here's we were just printing our response until now. We'll just run through a loop on our response, where whatever data we have will be of the format response of the type response we just created earlier, and this will, if we have assigned some value, for example x equal to 5, that's an assignment operation, but 5 plus 5 is not an assignment operation. So if there is an assignment operation, true, we have to set our ticked off variables with just whatever was already in that, so a spread operator there and a data expression result. Expression will be x and result will be whatever we set x to. So if we later use x into 5, it will give us 25. Now we have to find the center point of wherever we drawn, so that our latex is rendered at the exact center of where we drew whatever we drew. For that, I will just call our ctx. Here we'll just take our image data of our canvas and run through a loop. Since it's an x and x into y matrix, we have to run through a n square loop for I in range of our x coordinates and for j in range of our y coordinates, and then we'll just find our max x and max y point where we had drawn stuff, and that will give, and that averaging that will give us our center of x and center of y. So let's do that. Now we can set our latex position to the center points. Center X and center Y. And then just another go through our loop. Set for each. Resp.data for each. Data response. And set timeout because to set this asynchronously. Set result to our expression and the answer, and this will take what 200 milliseconds maybe. I think it's looking great now. There are no errors in our file. Let's check it once. Okay, we have not set our latex position yet, so let's go do that on our canvas. And now here I found a really nice component so that we can also move around our result or rendered result, called draggable from React. Draggable. I think I have installed it already. If not, you have to just open your terminal and run React draggable, and it will install the component. Beautiful. Close this terminal and let's go to our canvas. Let's write our latex expression here. We have to only do this if there is some latex expression already stored in our state. So we'll write a conditional map like this. It will not run if latex expression is undefined or null. It will never go to the second part of code. But if it is true, then it will go to our second part. We'll need some index for our map. There it will be a parenthesis, not draggable. It seems correct, but I'll write it anyway. Key index. There will be some default position, which will be our latex position. Latex position, and wherever an on stop function prop, which will tell the draggable what to do when we stop dragging around with our mouse. This will take in the event and data, and it will just set our new latex position to that new point. We'll just close our draggable component, and finally we need a div that will take a class name for absolute position. We'll just keep it simple, white text, and this will give another div for our latex content. Its class name will be latex content. You can just write it on same line, and it will take our latex state. Beautiful. And finally our project is completed. Let's go test this for the last time. Let's just start by some assigning operations. X equals 8. Yep. Y equals 10. Yep. And let's do 2x plus y. This should give us 16 plus 10, 26. Yep. Let's do another one. Some basic integration, d by dx for x square. Yep, it has given us 2x. So as you can see, it's all working perfectly now. Our maths is being matched and it's being rendered beautifully in latex. Our colors are also working fine. Our buttons are working as well. Alright guys, we'll see you in the next one. Until then, happy coding.